This video is about Central Limit Theorem. I will explain this concept by going through this example. Assume that cans of Coke have a mean of 12 ounces and a standard deviation of 0.11 ounce. A. Find the probability that a single can of Coke has at least 12.19 ounces. If weights of cans of Coke are normally distributed, we can draw a bell curve like that. So here we know the mean is 12 ounces and the standard deviation is 0.11, and we want to know the probability of a single Coke that is at least 12.19 must be here. So we're basically looking for this shaded area. If you want to find this area using a chart, first you have to find the z-score. The z-score of 12.19 is equal to, first, the number you want to find the z-score for, 12.19, minus the mean, which is 12, divided by the standard deviation, 0.11. If you go through the calculation, we can round it to the nearest hundredth by 1.73. And then in the A2 table, you want to find the corresponding area. So this is the z-score table, and the z-score of 1.73, the area to the left of that score, that z-score is 0.9582. So that means to the left of that z-score, the area is 0.9582, but we're looking for the area to the right of it, so you will use 1 to subtract 0.1582. What you get is 0.0418, which is the answer to this problem. Another way to find this probability is to use StatCrunch. So go to StatCrunch, go to Stat, under Calculators you can find Normal, click Normal. Right here, mean, put the 12, standard deviation, we're given the standard deviation of 0.11, and we want to find the probability of values greater than 12.19. Compute. You will find the shaded area is 0.042, which is a little bit different comparing to what we found in the chart. The difference here is, since we rounded the z-score earlier, it's not as accurate as the StatCrunch, but the answers are pretty similar, 0.418 versus 0.420. That was the A part of the question, find the probability of a single can. So now let's look at the B part. The 36 cans of Coke have a mean of 12.19. Find the probability that 36 random cans of Coke have a mean of at least 12.19 ounces. We're not dealing with a single can anymore. We're dealing with a sample of 36 cans. We're not using the same normal distribution as before. We're using an adjusted normal distribution for this sampling distribution. For this sampling distribution, the mean is still 12 ounces. It's still the same as your population mean, because the sample means target the population mean. Remember from 6.3? However, the standard deviation of this new distribution has changed. Is not 0.11 anymore. It's 0.11 divided by square root of n. In our case, this n is 36. So that's 0.11 divided by square root of 36. And the answer, we can round it to 0.0183. So now to find that 36 random cans, a sample of random cans, has a mean of at least 12.19 ounce. Still it's 12.19. You have to use this new distribution. Same mean, again same mean, but the standard deviation is changed. Okay, so if you want to do it by hand, you will find the z-score first. Well, the z-score is still 12.19, the number you want to find the z-score for, minus the mean, here's still 12. But here you want to divide it by the new standard deviation, which is 0.0183. If I round my z-score to the nearest hundredth, I have 10.36. And this is such a big z-score. If you go to the chart, you probably can't see it. So the probability of finding a number with the z-score greater than or equal to 10.36 is almost 0. So the probability of finding a sample of 36 cans with mean of weight greater than or equal to 12.19 ounces is almost 0%.